So here it is, my finished entry for the Great Guitar Build-Off 2022. A bit of an experimental design, this one. My first attempt at making a serious guitar, but it seems to have worked out quite well. As you can see, it's a headless design. The tuners, however, are built into the body of the guitar, unlike the normally commercially available tuners which just sit on top of the body. So I've designed and built my own tuners, as you'll see later on in the video some details of how that was done. Access for fitting the strings is from the back, so my wife suggested we use clear back covers for this, bit of fun. You can see everything that's going on inside here, so magnetic lid makes it available to quickly get into the back for changing strings. One of the things I wanted to try with this guitar was making a wider neck. Just about the only thing I'm good at when playing guitar is muting adjacent strings when I don't want to. So I decided to make the neck significantly wider than is normal for an electric guitar. This is actually 50mm at the nut. Not quite the width of a classical guitar, but it's getting there. One of the reasons for making a bolt-on neck for this guitar was that if I really don't like this, find it unplayable, I can make a new neck rather than have to make a whole new guitar. The controls, as you can see, are not particularly obvious on top. I thought if we're getting rid of the ironmongery with the tuners, it might be nice to make a fairly minimalist design that shows off the wood and the surface of the guitar. The controls are here on this cliff edge. So we have a three-way selector switch here and 5 potentiometers with just the edges of the knobs visible. 5 knobs because I intended putting active electronics in this guitar to have quite a great deal of control over the sound coming from it. Unfortunately, I seem to have a greater talent for making a broadband noise generator than a working set of electronics at the moment. So for the time being, this is simply a 3-way selector switch and 1 master volume control. The decoration on the guitar was designed by my wife Christy and is made using epoxy resin rather than inlays. And she also wove this strap for me, which is in complementary colours for the decoration. So that's a really great addition to the instrument. So, what does it sound like? The first part of the guitar to be built is the central block for the tuner assembly. This rather complex shape might be difficult to cut by hand, but I'm using my CNC router that I designed and built for myself to make most of the parts of this guitar, and so this has been a very good test of the machine and my ability to drive the software that operates it. A special jig had to be made to hold the very small block of wood in place while the machine did the cutting. blank that the body is made of is a bit larger than the usual blank for a guitar body, and I made this one by laminating together planks of Tasmanian oak. The blank is then drilled and mounted onto a jig fixed to the base of the machine. Special software is used to design projects for use on a CNC machine. It contains both the CAD, computer-aided design side of the program, which is used to draw the guitar in the first place, but it also includes a system for generating the instructions which will then drive the machine to cut out the shapes that you've drawn. There isn't much room for improvisation here. There's a lot of drawing to do before you can even begin cutting the first piece of wood. Once the tuner block was completed, the body blank and its jig could be fitted to the machine and machining on that part of the guitar begin. Here you can see the cavity that the tuner block gets glued into, and also the controls cavity, which seemed quite roomy at this stage. The tuner block is then glued into place and becomes an integral part of the timber body. The body blank is fixed down into the machine using bolts which go straight through the jig and into the fixing clamping arrangement in the bed of the machine itself. However, getting them accurately positioned is done with these 3 pegs, which are a tight fit into holes drilled in the jig itself, and then the whole thing will sit, if you're very lucky, and go down there, and that's very precisely positioned and then held in place by the clamps. One of the reasons for doing that is to be able to turn the whole thing over, to be able to machine the top accurately and get the top and bottom holes to line up by placing the jig, placing the blank the other way up on the same 3 pins. So now I have to start machining the top. Here you can see the machine fitted with its highly sophisticated dust extractor shoe. This actually makes a great deal of difference to the amount of hoovering and sweeping up that's needed after the job's completed. Once the cliff edge and the holes to allow the controls to come through have been cut, it's time to fit the layers of veneer onto the top of the body. Here I'm using West Australian she oak, which I hope will give a nice effect once it's all been varnished up. Because the guitar body has a cliff edge here, so that the body steps down to make room for the knobs, the edge of the control knobs just sticking out of the edge here, the piece of veneer that goes onto this has to be cut in advance so that it can sit neatly down in here like so. And then there's 8mm for the knobs, and then another layer of veneer will eventually sit on top here. Once the remaining top veneer is glued in place, then all of the remaining machining on the body can begin. The cutouts on the back are all completed. The veneer has been stuck onto the top. Pickup pockets have been cut, slots for the strings. Most of the top cutting is done now. Still left is the scary bit, which is the neck pocket. Now this guitar has a neck which will slope back at 2.5 degrees. It's a bit more Les Paulish than Stratocaster. And rather than try and persuade the software I'm using for design of the guitar and cutting out on the CNC machine to do a 2.5 degree slope, I've decided that the easiest way is going to be to tilt the jig with the body on it up by 2.5 degrees. So that's the plan. These 2 blocks, cut on the CNC machine itself of course, just lift up the jig enough to be an exact 2.5 degree slope. All the machine now has to do is cut out a nice simple flat bottom pocket, which is much easier to program. I'm going to make a single piece neck for the guitar out of this piece of West Australian Jarrah. It's been sitting in my workshop here in Tasmania for about 2 years now. Prior to that, it was in my previous workshop in the tropical end of Western Australia, a much warmer climate, for a year or so. But having a look at it, it still seems to be remarkably flat and straight and level. And So hopefully that bodes well for a nice stable neck from this piece of wood. The neck blank is fixed onto the jig in a similar way to the body blank and is then skimmed down to the required thickness. Here we can see the machine cutting the groove for the truss rod. And it fits! The fingerboard, which is being made from Huon pine, same as the tuner block, is glued on top and then skimmed to thickness. My wife Christy produced designs for the neck and the body, and then once photographs of what she'd done were scanned into the computer software, I was able to draw over them in spline curves in order to generate instructions for the machine to cut them out. The CNC machine is capable of hogging out large amounts of timber when you want it to, but it can also do very delicate work with this 1mm bit, for example, which was used to cut out the decorations for the guitar. First, the central stalks were cut out for both the guitar and the neck, and then filled in with a brown epoxy resin. Once that resin was set, we could then go on and cut out the leaves, which were filled in a similar way with 2 shades of green epoxy. Once all the resin is properly hardened, a thin skim over the top of both the body and the neck will remove all the excess and reveal the pattern as it should appear. I haven't mastered the art of using 0.5mm diameter tools without breaking them yet, but this fine pointed engraving tool was able to mark out the positions of the frets for me. It can do the job much more accurately and much more quickly than I can do it with a ruler and a pencil. Having received a Shinto rasp for my birthday this year, I was always intending to shape the back of the neck by hand. First of all, I had to cut out excess material at the sides of the neck in order to do that job. At some point in cutting out the neck, I'd made a mistake, so the one you see here ended up being split in half to rescue the truss rod, and a complete new neck made from scratch. Once I was happy with the shape of the back of the neck, I then used a fret saw to open up the grooves made by the engraver so that they'd still be visible once the neck had been radiused. I also took the opportunity at this stage to drill the holes for the neck marker dots. Radiusing the neck to 12 inches was then done using the CNC machine, which means a great deal less sanding has to be done to finish it off. And then the final job done on the CNC machine is to temporarily fit the nut with a bit of double-sided tape and mark out the exact string positions. Once again, this is something it can do with much greater accuracy than I can. The safest way to then release the finished neck from the remaining pieces of the jig is to cut it away by hand. I thought I'd spare you the excitement of watching a 15-minute video of me sanding, but the finish I'm using on the guitar is a wipe-on wax oil, which seems to have worked reasonably well. Once the first coat was dry, I sanded it back with 600 grit paper and started all over again. The West Australian she oak veneers on the front surface came out very well, and here you can also see the Tasmanian oak on the back of the body. As this is my first serious attempt at guitar building, I haven't acquired many of the tools yet, but a little improvisation goes a long way. Beveling the edges of the frets freehand seemed to work okay, but it was much more tiring on the fingers than using the proper tool would have been. In case you hadn't realised it already, the string clamps that I used at the head of this guitar were not bought from Hipshot at $20 a pop. And now at long last, only a few days short of the competition deadline, it's time to start putting everything together. I don't know if there's a recommended order for building a guitar, but I started by putting the neck on, followed by the pickups. And yes, I did eventually remember to drill some holes for all the wires to go through. A CNC machine can do a lot of the physical cutting work for you, but none of the thinking. After the pickups, I mounted the ferrules for the roller tunematic bridge and secured them in place using the approved tool. After the adjuster screws were fitted, I made sure that the spacing between the screws and the mounting holes on the roller tunematic bridge matched each other exactly. This is an important test, one I learned from spedding. The next job is assembling the tuners. There are 2 ball bearings for each tuner, so the shaft is held quite firmly in place. There are 2 lengths of tuners producing 2 offset rows of 3. This allows the knob of the tuner to be larger than it would be for 6 in a row. A nylock nut on the inside holds the tuner shaft in place. The moving part of each tuner is made from a nickel-plated brass hexagonal standoff. These are used for mounting circuit boards and other components in electronics. They're drilled at each end and have an M3 size thread. By drilling out one end and filing as shown, I was able to produce the tuners. The tuners are simply wound onto the end of each M3 shaft, and then the top plate holds them in place. The guitar is strung from the back with the end of the string pushed through the tuner, up through the slot in the top of the guitar, over the bridge, and then secured at the nut end. The rest of the assembly continued with a 3-way switch and the plastic plate holding the 5 potentiometers in place. This is where I ran into a problem. The electronics cavity looks big enough, but as you can see, the potentiometers take up most of the space. So I had rapidly put together a very small circuit board containing the active electronics that I wanted to go in the guitar. In practice, this didn't work out very well. It was more of a broadband noise generator than a set of active electronics for a guitar. So it was all ripped out, and the guitar you hear being played in the video simply has a 3-way switch and a master volume control. It'll all be sorted by next year.